Hello everyone, welcome back to Power System, class number 7. Today we're going to talk about auto transformer and voltage regulation. So, auto transformer. Auto transformer, let me go back here. All right, auto transformer is a transformer that is connected electrically as well as magnetically. That means this one here, this left transformer over here, is only magnetically coupled, only magnet. That means flux come here from the core and magnetically coupling them. There is no electrical connection. Now, if we make this transformer such a way that is not only magnetically coupled but also electrically connected, that means if I connect this from here to this side over here, that will become this one, right? So in that case, I can high side could be using both coils and low side will be using one of the coil. For this diagram here, high side using coil 1 and coil 2, and low side using the secondary of magnetically coupled coil. So this one is magnetically coupled, this one is magnetically coupled, also electrically connected. So that's this transformer over here, magnetically coupled and electrically connected. This kind of transformer or transformer you can only use where your electrical isolation is not required. If electrical isolation is required, you cannot use auto transformer. So let's get to this transformer here. For the current relation over here, so over here this I1 coming in and I2 also coming in this node over here. So IL is basically adding both current together, right? So over here, if you look this current over here, let's say N1 I1. So N1 I1 right here. Let's get a different color. The power here, so not power, N1 I1 over there. Then over here for the 2 part over here, the current I2 will be, let me tell you why is that. So your IL is I1 plus I2, right? So your I2 would be IL minus I1, that's right here. So the N2 times IL minus I1, if I do the math, rearrange the equation, will be like this, right? Okay, so now, so I1 or IH over here, this current over here would be same current, right? So that be IL also can be arranged like this. So now if I take the ratio IL over IH, I get 1 plus A. What is A? A is the turns ratio, which is basically turns ratio between two coil N1 and N2, right? So that is your high side and low side current relationship between them. IL over IH will be 1 plus A. All right, so let's go back to the voltage relation here. So now let's try to find the voltage relation here, okay? So again, A over here is N1 over N2. If you come back here, this A is basically N1 over N2. All right, so now over here again, the same connection. Let's try to find the voltage relation over here. So VH over here is adding both voltage, V1 plus V2, so adding this one and this one over here. And so now V2 is over here, right? So V1 can be straight right like this one here using this equation over here. So V1 is what? N1 over N2 times V2. Then over here, N1 over N2 is A, right? And V2 is basically VL over here. So then there will be 1 plus A VL. So that is your VH, right? So now VH over VL also 1 plus A. So now if you take VH over VL, if you take the VL out of here, then it's 1 plus A. Again, A is what? A is N1 over N2. So this what is saying over here, you normally your secondary over primary, let's say v1 over v2 is n1 over n2. This a now you have over here is 1 plus a. That's means this ratio is higher than traditional magnetically coupled transformer. So in magnetically coupled transformer, we have only A. Now you have 1 plus A, which is the voltage ratio. All right. So now let's try to find the power rating. So auto transformer, the power rating, if you look at the power rating here, I1 current coming in through this coil over here, right? So that I1 current goes through both I1 and I2. Look at the I1, I2. So V1 plus V2 times I1. That's the rating for the auto transformer, and the regular transformer is V1 I1. So that means your rating also, auto transformer rating also increase from your regular two-wire magnetically coupled transformer, right? So why auto transformer? Auto transformer, you can have more power rating. Your power capability would be higher than normal transformer using the same coil when you connect them magnetically and all as well as electrically. All right. Let me go back here what I'm talking about. So if you try to get the current rating over here for this one over here, the voltage rating I would say is normally you have for this one you have V1 times I1's current rating over here. So V1 times I1, that will be the power rating. Over here, your V1 plus V2 times your current will give you the power rating. So power rating is higher than your magnetically coupled transformer. That will be evident if you do this. On the example here, we'll see that how it changes. And there are some transformer out there. It's called three-winding transformer. What is that actually? Three-winding transformer, you have, I'm going to draw it over here. So let's say you have a transformer that this one here, primary, secondary over here. Then in between you have a transformer is Y connected. So this is primary, this is secondary, and this is called tertiary. Right? Why is this? This tertiary transformer sometimes used for two reasons. One reason is that to reduce or cancel out third harmonics. So this delta connected transformer does not have any third harmonics. If you add all the third harmonics, it can become zero for delta connected transformer. Then second thing is that when there is a fault, you need a path for zero sequence current. We only know positive and negative sequence. There's another sequence called zero sequence. So you need a path for zero sequence current. So that delta transformer will provide you path for the zero sequence current. For this reason, sometimes we use a third winding in the transformer for the tertiary transformer. If that happens, how do you find the individual impedance? ZP, GS, and GT. ZP for primary, GS for secondary, and GT is for tertiary. This is the equation you can use to find those values. Again, if we do this problem here, we'll see why auto transformer has more power capacity than normal transformer. Then we're going to talk about voltage regulation. Voltage regulation is done for a few things, is to control reactive power flow, because if you change the voltage, you would change the reactive power flow, and also control the phase angle. If you control the phase angle, you can also control the regular power flow. Two commonly used method is step changing transformer and regulating transformer. So we're going to discuss both of them. As you know that from the previous equations, you have real power equations over here and reactive power equation over here. So real power equation mainly depends on angle difference. If you change the angle between two nodes or two buses, you change the real power flow between them. And if you change the voltage, you change the reactive power flow. So if you change a tab in your transformer at one node, that either change your voltage or voltage and angle both, then will change the power flow in the network. So tap changing one is that, let's say for this one, let's say this, you see, this is 1:3 ratio, it is 3:1 ratio. Then let's say your VR over here, VR is VR, this ball is right here. Then you add the losses in two components here. You can see as we discussed before, then you have the VS right here. So this is the diagram for that. So VS is VR plus R plus JX times I. And again, this one and this one, we have seen that 1 times 3 and 3 times 1. So if I make the adjustment here, is to be 3 times 1/3 will give you 1, right? And so if I know the TS, sending and transformer tap, then I can also find the receiving and transformer tap. So the sending and tap could be found by this equation over here. P2 prime, I2 prime is given. Then your real power and reactive power, real power multiplied by R, reactive power multiplied by X, divided by 2 voltage will give you the TS. So sending and tap, then if you know that tap, you can find the receiving and tap by using this equation over here. Then you can adjust the both transformer tap to give you a voltage you wanted. That would be these 2 volts over here. All right. And the regulating transformer, how does it work? Look at here. If in this position right now, you have here and here. So let's say that you're not changing this. This is fixed, right? This is fixed, right? So, and at this point, let's say that your notation here, this notation is the polarity. If this is positive, this side is all positive. So if this one is positive, this one will be positive. If this one is negative, this one is negative. Let's say both are positive. Then at this position over here, if you look at that, at this position over here, this is the negative now. So this will get negative, this will get positive, right? That's good. Now if I change the location of the switch, if I switch come over here, if the switch come over here, this is not changing, right? So what will happen now, this side will become positive and this side will become negative. Let me go back and change this over here. It was negative before, then now it will become positive here. So now it's polarity changing when you're changing this two switch over here. That means at the end, if you add them over here, you can add or subtract this amount of voltage, because this is the voltage inducing on the other side. So if we're trying to find this one here with the tap, with the regulating transformer, your voltage is not VAN anymore, is VAN plus minus this amount here. So you can adjust your voltage of the transformer by this amount. This amount is normally around 5% or less. So you can adjust the voltage of the transformer output by around 5%. So that adjustment will give you some power to change your reactive power flow. And over here, now if you have the transformer there, but in a little bit different arrangement, so you have before you have that in phase to neutral. Now you have line to line. So you have line to line here, same arrangement line to line here. So what will happening? This one is line to line, right? BC, right? So you are having AN. So AN is right here, right? Then you're adding little bit of BC over here. Can you see that? So now if these two vector addition will give you this voltage over here. So this voltage is in different magnitude, also has a different angle now. It's not zero angle anymore. So this one will change. This one will have the new magnitude and angle. So this one, the phase angle control changes magnitude as well as angle. That means when when angle changes, you can change the reactive power flow, and magnitude can change the reactive power flow. So this, with phase angle control, you can change both reactive power and real power flow. So regulating power flow, you change a small amount. So you don't have to change the tab. You're basically using a transformer inside the transformer to change the small amount of voltage. That voltage change could be happening automatically while you are loaded. Your transformer is loaded, and that change is less than 5%. Less than 5%. If you do more than 5%, you have to take the transformer out and do it manually. All right. So that's the one advantage of regulating transformer. We're gonna do this problem in the class. That's all for today. I'm gonna see you all for the next class.